Topic that I'll be teaching is kinematics, which is A1 in the new 2025 syllabus. But well, that's what I'm studying anyways. I've skipped uncertainties, but I'll get back to that later because it is a really important topic and you need to know how to use that. And it is kind of tough to understand and master, but once you get the hang of it, it's sort of easy. Now, the first thing you need to know is just scalar and vector quantities. What are those? I would presume that you know this, but in case you don't, a scalar quantity is one that basically takes into account only the magnitude or the value of the quantity. So let's say speed. In any direction, your speed is still 5 meters per second, even if I'm moving there. Right, so the next thing is vector quantities. What is a vector quantity? A vector quantity is basically one that that considers magnitude and direction. Now, what does that mean? Let's take, for example, velocity. If I move forward at 5 meters per second, and then I decide to go backwards at 5 meters per second, then when I'm moving forward, my velocity is plus 5. When I'm moving backwards, which is the exact opposite direction, it's minus 5. Next thing is distance and displacement. Distance is basically a scalar quantity and it's what speed is derived from. So distance, how do you calculate that? Well, any direction you move in, it's all counted in distance since you are moving. But displacement, that's the change in position. So let's say I'm moving in a circle like I've shown here. Then there's no displacement being done since my initial and my final position are the same. But there is movement, so there is distance being covered. And that's how that works. Displacement is used to derive velocity, whereas distance is used to derive speed. Now we move on to average velocity versus instantaneous velocity. So how does that work? Average velocity is basically if I'm moving at 3 meters per second at the start and I end with 5 meters per second, then my initial plus final upon 2 will give you my average velocity, which will be 4 meters per second in this case. And another way you can calculate it is using the formula S by T, which will always give you the average velocity in any case. Then instantaneous velocity. How do you do that? Well, for example, we have projectile motion. Then if you have the displacement time graph, you can find the gradient of the displacement time graph at any point, and that'll give you the instantaneous velocity. And there's no other way to find instantaneous velocity. Another basic quantity that you need to know is acceleration. What's acceleration? Well, it's a vector quantity and it's the rate of change of velocity. So if initially I'm going at 4 meters per second and then the next second I'm going at 5 meters per second, then my acceleration will be final velocity minus initial upon the change in time. Okay, let's move on to relative velocity and vector addition. So let's say I'm on a ship that's moving north at 4 meters per second and I'm moving east at 3 meters per second. Then what's the total velocity, right? You have to use Pythagoras theorem here because it's vector addition. So let's say 4 meters like this, 3 meters in the east, that's going to make a triangle, and if you find the hypotenuse, that's going to be 3 square plus 4 square and the root of that, which will be 5. So your total velocity is 5 in this direction, northeast, or not completely, but yeah. So next we have to move on to SUVAT. How does SUVAT work? Well, S stands for displacement, U stands for initial velocity, V stands for velocity, and A stands for acceleration, T stands for time. So you'll just need to remember these. Okay, so whenever you're using SUVAT, you have to make sure that acceleration is constant, since that is one condition that has to be followed. Otherwise, these equations will not work. So the two supplementary equations we'll be using are these two. And since A is constant, we can also say V is equal to V plus U by 2. You don't need to remember that. It's basically we're just using it to derive these. So the first thing we'll take is this equation, S is equal to Vt, and we'll just substitute this into that, and that's your first SUVAT. Now the next one is just A is equal to V minus U by T. So we've taken this one in this case and we've just rearranged it. So T will come here, will become AT, and U will go here and become plus U. So V is equal to U plus AT. That's your second SUVAT. See, this is pretty easy. Now next is S is equal. So here we're gonna take both of these, as you can see by the arrows, and S is equal to V plus U by 2 into t. So since we just proved that v is equal to u plus at, we can put that in. So s is equal to u plus at plus u upon 2 into t. You just simplify that further to get this third SUVAT, which is s is equal to ut plus half at square. And now the fourth one, we're going to be using this and this first equation, a is equal to v minus u by t. Now we can rearrange that by taking a here and t there. So v minus u by a will become t. And here, remember this one. So here let's make t the subject. So t will be equal to 2s by v plus u, as I've shown here. And then you substitute that into t. So 2s by v plus u is equal to v minus u by a. So v plus u into v minus u is basically a difference of squares. So you use the difference of squares formula, and you can just take v square minus u square. And even if you take it the normal way by expanding the entire thing, it'll give you the same answer. And a will come here and become 2as. So then the final equation will become v square is equal to u square plus 2as. And that's your fourth SUVAT. And that's SUVAT done. Now we have projectile motion. So projectile motion is when the only force acting on a body is gravity. So let's take the case of this ball that I've drawn here. It's moving from A to C. So let's say a kid here has thrown this ball at the speed of v at this angle theta. So due to gravity, it's basically going to dip down eventually and reach C. Now when we begin with velocity v at angle theta, then using the vector addition formula or whatever we learned, right, you can use the trigonometric ratios to find out that the vertical component is v sine theta and the horizontal component is v cos theta, since adjacent upon hypotenuse and opposite upon hypotenuse. Now, what we need to know is how each varies at each point. So at A, for t will be 0, and the vx or the horizontal velocity will be v cos theta and vertical velocity will be v sine theta. And displacement, both horizontal and vertical, is 0 at this point, since it's just beginning. And at B, or over here, t or time basically is equal to t, the total time, upon 2. And vx or the horizontal velocity will still be v cos theta, since there is no friction, no nothing, so no deceleration for the horizontal velocity. Then vertical velocity here will be 0, since it's at maximum height. So it will increase as it moves up from A to B, and then start decreasing and go into negative as it moves from B to C. So here it's going to be 0. And Sx, or horizontal displacement, is r by 2. R is the range, which is A to C. And Sy, or the vertical displacement, will be equal to h, which is the maximum height that the ball travels. Now, remember, A is constant, so we can use SUVAT, but we'll get to that later. Acceleration is minus g here, minus 9.8, which is the value for g. Now, at C, t2 will be equal to t, the total time, and vx is still equal to v cos theta, and vy is now equal to minus v sin theta. So here the signs are flipped, and sx will be equal to r, or the range, and sy will just be 0. And that's basically how projectile motion works. That's the only thing you need to know. So next we're going to look at 3 equations that are really important for SUVAT, and I'll show you how we derive these. So let's first look at the horizontal aspect of everything. S is equal to Vt. So range, or the total displacement, will be equal to the horizontal velocity, which will be v cos theta, into t. So you can always use this to find the total displacement of the ball. Next we're going to look at the vertical aspect of things, and remember the SUVAT v square is equal to u square plus 2as. We're going to apply that at point B, where, remember, vy, or vertical velocity, is 0. So v square, which will be 0 square, which will be 0, will be equal to u square, which is v square sine square theta, and minus 2 minus g. Remember, a is minus g, so it'll become minus 2gh. And you can basically rearrange it to find this equation, which is extremely important to find the maximum height using only the value of theta v and v. since g is a constant. Next is s is equal to ut plus half at square at point C, where vertical displacement is 0, remember. So 0 is equal to v sine theta t minus half gt square. Now you can use the quadratic formula to find the value of t, and you'll just get 2v sine theta by g. Or you can just take t common here and use that way. Any method is fine.